Okay, thank you very much for the invitation, for the nice introduction. So it's actually great that I follow RecSys now, because RecSys comes from a big organization with lots of data, lots of capacity for running their own experiments. And the work that I'm presenting here is about a very different type of company. So a company that is actually not so interested in creating their own algorithms, but instead is trying to make sense of what is out there, to be fair. So the work that I'm presenting is joint work with Dimitrios, Yaron, Mikola, Monica, Naver. And that was presented at the time it was called the FedStar conference in 2019. And it's all about a simulation framework. So we don't have live data, we have a simulation framework to understand the effects of recommender systems. And in the specific case of the online news environment. Now, the online news environment has a reason. So this is part of what's called the Fair News project, where we collaborated as computer scientists, communication scientists, and information law scientists. And the goal of this project was to investigate equal access to news as a requirement for a well-functioning democracy. And of course, then the next question is, well, how do we define equal access to news? And part of this project was a big, at least for the Netherlands, a big national newspaper. And that big national newspaper, of course, has a webpage where they also recommend articles to their readers. So people can get a monthly abonnement, they can get a prescription, and then they get some articles. And well, we asked this company, well, how do you decide how to recommend these articles? And they had basically outsourced it to some company. So we went to this company and we asked them, well, how do you do that? And they just used some off-the-shelf tool, and they didn't even have logs. So it was very much like a point of, well, we do recommendations of articles on our newspaper website, but we don't really know how, right? And of course, well, that doesn't really work. As a news provider, you should be able to know, well, what is the impact these recommendations have? And so this was partially what this project was about. And then the information law scientists also, of course, came up with a lot of ideas and a lot of their own definition of fairness, which is very interesting from a computer science perspective, because we like our equations and we want just to be given an equation of fairness. And of course, if you come from the other side, communication sciences, law, it's not as simple. So in this particular project that we had in this new setting, we have the content providers. So they want to increase user engagement, satisfaction. They want to sell more monthly prescriptions to their newspaper. But of course, they also have to be fair in how they expose different views to their readers. And on the other side, we have the consumers, that have to deal with this information overload through these filtered and personalized suggestions. And one of the first things we did in this project is to actually talk to this national newspaper. And we came away with the idea that, the stakeholders there on the newspaper side were very much overwhelmed with, well, what are the recommender algorithms actually doing, right? They are very opaque. They appear to be complex to, outsiders. There's no transparency, even for the content provider. So they just hired a company to give them some out-of-the-box algorithm. Users, of course, cannot control what they see. It's like a black box to them. And as RecSys also mentioned, typically we have the rich get richer effect. So the popular articles are getting promoted more, and maybe the niche topics or the less popular articles in the news, they get recommended, not so much. Right. And the open question is, well, the recommender algorithms that you're using, are they reducing the diversity of things people see? Or is it not so much a problem? And as I said, in this news industry, there's really now this movement that we need to take into account what type of content, what type of viewpoint, and what type of opinions we allow people to see through these recommendations. Because as in other domains, we know very well that a lot of what people view is really based on the recommendations they receive, right? And the media form is an arena for public debate, and so it is necessary that there is that the readers of these news websites, they see and read this diversity of voices. And so this is where we came in this project. Once we realized very quickly that actually the news provider as a stakeholder had very little idea of the impact these algorithms have, we were thinking, well, we should show what this impact is. And once we realized that there actually is no data at the content provider, well, we went down the simulation route. And so in this work, we contribute this simulation framework, which we call SIREN, which simply stands for a simulation framework for understanding the effect of recommender systems in news. And we didn't build this from scratch. We took this from an existing consumer behavior model that I described in the next slide, which is very popular. It comes from the management sciences. It was about sales diversity. And we adapted this simulation to this news context, right? So this gives us our model, which we implemented. And then we could basically look at, well, what is the effect different recommender algorithms have on the diversity of articles that users are being recommended, right? Purely from a simulation point of view. So let me quickly introduce this base model we started off with. It comes from Flede and Hosanaga, which is a very popular and also very simple model in the world. So this model works as follows. We have a 2D attribute space. So if you have high dimensional vectors or features, you have to compress them down with PCA t-SNE in a 2D space. And in this 2D space, we have products and consumers, right? So as I just said, in this model, it's about sales diversity. So products are items to buy and consumers are the people that are buying these items. And these people and these products reside in the same space. So in this example, we have the dots that are products and the blocks that are consumers. Now, a consumer is of course not aware of the entire space of products. The consumer is aware of two types of products. The products that are universally popular, and those in this space reside around the 0 point, so 0, 0. That's a dot you see in the middle, the ball. And then the consumer is also aware of the products that are in the proximity of his current position. Right? Now, what happens then is a recommender system recommends products. And then in every iteration or every buying period, the consumer makes a decision either to buy a product or not to buy a product, right? And once the consumer has been exposed to these additional products through the recommender, then the awareness of the user shifts and we can continue this iteration by iteration. Now, if we translate this to news, of course, we don't have products, we have news articles, right? And we don't have consumers, we have readers. But the basic principle holds. And so what we did is we took this base model and then we said, well, how do news differ from sales? Well, there are a couple of differences. So one of these is the mechanics of article publishing and consumption is quite specific to news. So articles are published at very regular intervals. We know a lot about how they're consumed. So typically they're consumed almost immediately or within a few days of them being published. They're rarely consumed weeks, months, years later. We know there are specific intents that users and content providers have. So on the news platforms, there's a lot of usage of what's called editorial cues, like the font size, the positioning of the articles, to draw the reader to certain articles. This is done by the content providers. And we also know that news readers, many users that read the news, they're not so much in this, well, show me something interesting, but instead they actually have quite set ideas about what they want to read about. It's quite different from music, where oftentimes we want to recommend like relaxing music, but in the news world it's a bit more set, right? And so we take this knowledge that we have from the literature and we build it into our basically adapted model. And so what can we do then? Well, we implemented this in a toolkit called SIREN, and so this toolkit then allows content providers to basically go ahead and fix the parameters in a specific way, so that we have a couple, so that these parameters reflect how they see their news organization, what their values are, what the publishing habits are. So are they publishing 10 articles a day, or are they publishing maybe 10 articles a month? They can also use those variables to define, how their readers are and so on. And as part of the toolkit, we also have different recommender algorithms, just standard algorithms, that we can then try out to see the effect that these algorithms have on the diversity of materials that users are likely to read. And so you also need metrics for this. So in this particular paper, so it's very nice that Pablo follows up because it's one of his papers. So there are two metrics that we implement. One is a long tail diversity metric and one is an unexpectedness diversity metric. And let me show you very quickly how the tool looks. So this is a university project, so it doesn't look as polished as it could look. But basically, we have recommender settings where you can choose the recommender you want to use. We have article settings, so this is really specific to news, where you set as a news provider what type of categories you have, how many articles you have in each category, and so on. We can say something about the users that you have in your, that are currently coming to your news portal. And then at the bottom, in the bottom row, you see then basically the outcome of the simulation. So the outcome of the simulation is then, well, how does the diversity of the content users are exposed to change over time? Right, and I'll show you a little bit actual graph in a moment. So this is more like toys. All right, so how does then one simulation iteration look for our news environment? So we place the users and articles in the same 2D space as I showed you for this space model. And then we have one news cycle defined for ourselves as a given set of articles and recommendations. So this could be like one day or maybe half a day. As I said before, the users are aware of the articles in their proximity. They are aware of specific popular articles. So these are the ones that are promoted by the editors. And they're also aware of these personalized recommended articles, which are provided by any type of recommender you put in. Some of these articles will be read, and then we update the user preferences, right? And this news cycle then starts off again with a new pool of articles, new updated user preferences. And so how do we get to these articles? Well, since we live in a simulation world and we still have to start off with some basis, we went with what is seemingly very traditional in news recommenders. We went with a BBC data set to basically span up a topic space, which I think was 5 topics. And then we just went to the literature to encode an article's prominence. And so let me just show you 2 examples of what I mean we went to the literature. Well, basically, we looked at existing works. What kind of empirical finding did they report? And how can we translate these findings into formulas? Or sometimes we already took these formulas from existing articles. So for instance, for this prominence of an article, the literature is very clear that articles have a very short time lifespan. Most of the interactions that users have with articles on news websites are within the first few days of its existence. And so we can define the prominence of an article at a certain day X as a combination of, the publication lifespan, which we can set depending on the news provider, as well as the initial prominence of the article. And the initial prominence of the article, so this is Z0, that could be depending on where it's located on the front page, or is it even on the front page? But these are things you can set. Right, so here are 2 other examples. For the users, we need to define how the preferences change over time. So we have a probability of a user drifting towards a particular topic after having read the article, right? And so again, we just formulate this mathematically based on the literature. So in this example, we simply used, well, e to the power of the distance between the user preference in the 2D space and the article in the 2D space divided by theta, which is a bivariate normal around you, the user, that simply determines how much the user is willing to diversify in his reading habits. Of course, there are plenty of other choices you could make, but this is the one we used here. Similar, when it comes to user choice, So what does the user actually pick? How aware is the user of a particular article? And that is a combination of, the global prominence of articles versus the awareness of the user of the articles in the user's neighborhood. Right, so these are just two of the formulas we had, but in the paper there are much more. And of course, one thing you could say now, well, okay, what do we do with that, right? Well, once we have all these formulas defined, of course, then the next step is to say, now we can put them in our system. We can make sure that the, whatever we define as the variables are actually as related to the real world as possible. We can run the simulation, and then we can investigate, well, how does user behavior change? Does user behavior actually change? Are users exposed to more diverse articles? And so this is what we did as well. We took a data set from the US News, which had a couple of thousand articles. And as you can see in this table, I won't go over this, but basically these are all the settings you can have in our SIREN toolkit. And of course, these numbers, they do come from the literature. And if we didn't find numbers in the literature, we actually, we discussed it, and then we thought what we did, we set what we thought were reasonable sets. But that is always in the simulation, it's not. It's just an approximation of reality. So what did we find? So this is just one of the plots we have. So this is about the long tail diversity. So on the x-axis, you see the iteration. So basically the new cycles we expose the users to, the readers. On the y-axis, you see the long tail diversity. So higher is better. We want to expose the readers to more diverse viewpoints. And then in the different colors, you see different recommender algorithms that we plugged into our toolkit. And these particular names come from My Media Lite, which is just a popular standard open source toolkit, but you can plug any other toolkit into the system as well. So let me just focus on a few of these results. So if we look at the bottom of the plot, we see the most popular and the random recommender, as the name suggests. Most popular simply means we pick articles that have a high prominence value. And of course, if you just pick those articles, the diversity doesn't go up over time, right? Users' diversity does not change the type of articles they're exposed to. The same happens for random, which is just a sanity check for us. Now, interestingly, if we use something like item KNN, which is just K nearest neighbor, we do see that diversity is initially high and it just slightly increases. And we also see that item KNN, so this is the blue line, is actually provides us with the highest diversity in this setup. Whereas the weighted Bayesian personalized ranking, which is supposed to be a better approach, actually takes slightly longer to reach the same level of diversity. Now, most interesting to us was on the last finding here, when we look at the user K nearest neighbor, we see here two types of lines. So we see the solid lines, which is including this user drift modeling. So, we have this update of preferences every time, and how much the update is to the user preference depends on the type of articles the user has been exposed. So we see once the user preferences drift over time, the diversity increases. But then we also have the dashed lines here, the hardly visible lines, and they are here to show what happens if we do not include the user drift. So if we assume that actually the user, even if exposed to these additional articles, does not change his or her preferences. And then we see diversity remains relatively low. So it is important, and that's one of the main points that we make in the paper, is that the user drift is modeled really well, right? If the user drift is not modeled according to how it should be in reality, then the simulation will not be very useful. All right, so as I just said, so the recommender effects with respect to this diversity, in this case, the long tail diversity, are really dependent on the evolution of the reader's preferences, right? So it forces us to have a good idea of how these readers' preferences evolve over time. It also shows that studies that are just based on a snapshot of real life data probably do not give us a good idea of what's happening with exposure to diverse viewpoints in news recommended, right? You need to look at long-term effects. And lastly, as you also saw, since these different recommender algorithms, which are all mainstream algorithms, have quite a different effect of diversity, content providers do need to be aware of this, right? And they cannot, or they should not at least, simply outsource the choice of recommender algorithm on their website to a magic black box. All right, so in conclusion, I've just given you an introduction to this tool that we built. Of course, it's a university prototype, so there are always many other things that need to be done. It's designed to aid content providers, so stakeholders in news environments, to decide between different recommender algorithms and also to gain insights into the effects these recommender algorithms have. It's based on a particular type of seminal work by Fleda and Hosanger, and we took that work, that model, that simple model, and we adapted it to the news context. Now, there are a couple of limitations. One is, of course, that the news consumption mechanism we model is very simple. So we did not take any social media or user interactions into account. We also just used standard parameterizations of standard recommender algorithms. Of course, there are many more available now that you could and should test. And it's still also an open question, if now that we have the tool, what can actually stakeholders, so content providers, do with the tool, right? Do they reach the right decisions with this tool or not? That's it. Thank you very much for your attention, and back to Yashar.
Thank you very much, Claudia, for a very interesting talk. We have time for a quick question. I see that Ting has asked one. So she's asking, is this diversity per topic or in general, as it is a general diverse topics or diverse articles on a specific topic? And if it is the latter, how do we protect users from misinformation that poses as the other side of the story?
Yeah, very cool questions. So this is about basically giving you user profile, also being exposed to other diverse topics that do not align with your user profile. Now, misinformation is here completely taken out of the picture by assuming that we have one content provider, and we assume that content provider does not misuse that position to actually distribute misinformation. But here it's really about, if you think about, for instance, political debates, are you getting just your favorite party topic lines? Are you just reading those articles, or are you also being exposed to the arguments of the other side, right? But it's all from the same content provider in this example.